Uh, let's see. 1 second, guys. Yep. Okay. So in this stream, I know I've been doing many streams lately. Well, I'll get back to actual videos. I'll get back to the OpenGL once I get that OpenGL book and I can read OpenGL. In this stream, I am trying to do ATOI, the ATOI function in 8080 assembly. The reason I want to do this is because in my YA term, I want to be able to change your character delay and line delay, and I want to be able to do that. Actually, I just thought up of a way to do that. Hang on. To change numbers, hit character, then do plus or minus, plus or minus to change value. Cool. I will work on that. But the problem with that now is how do I reflect it? So that would be ITOA. Then do ITOA. I would need to do an ITOA function. I need to do ATOI. Basically, originally what I was going to do is I was going to do a you go in and you type in the number, but it's really difficult. Okay, basically I have to figure this out. How do I do this? Basically, I want to. Okay, so where I'm at is this is in boilerplate. I print the message. The message is going to say input number. Okay, it's going to input number, call printf, and then call read and buff. Read and buff reads in the stuff you type. And according to the wonderful CPM interface guide, which I highly recommend you guys get a copy of, if you read function 10, read console input, basically it's saying the first byte is going to be the number of bytes you want to read max. The next byte will be how many bytes you actually read, and then before you hit enter, and then the rest of the bytes is your characters. Simple enough. Very, very, very good book. I got the entire suite of these manuals. Please, if you find them, please get them. They are amazing. Okay. Anyway, so I have the number. We're gonna do so that this here is my no. Okay, our ATOI die ESM ATOI load ATOI input number 1 2 3. Cool. So that's what I do, and then it just sets the buffer. The buffer down here is this in buff. I'll do +2 instead of +3. Anyway, and right here, read and buff is confirmed to work. So now I have to break apart my my thing. So break apart number string. So this is what I'm going to do. I'm going to LXI H. I'm going to load HL to in buff +2. I'm going to move. Hang on. How do I load? No, I need to set LXI H in buff LD HL. Load HL in buff. Hang on, folks. Hang on. Move register to register, move immediate to register. Register, load A from memory, LDA. So cool. Basically, so the accumulator has length HL points to first char. It does destination source CA. Move to C. We're not using C8 assembly. Okay, so C is the counter. How do I want to do this? I want to get the first by itself. How do I do this? How do I do this, folks? Okay. This is what I'm gonna do. So right here, in buff plus 2 is what I want. Is there a way to increment HL? Hang on, I'm on the verge of... I did this once before. Basically, I want to get the first number Okay, let me write this out in pseudocode first. Okay. For I equals C, I is greater than 0, I minus. No, well, ideally, but I don't care too much. I plus. Temp I equals in buff I. That is the pseudocode I want to turn into assembly. Okay. So I do nothing with this first. Let's figure this out. Let's figure this out. Okay. Get C. LDA. Lad. LDA. In buff. +1. Load accumulator from in buff +1. In buff +1 is the load of chars typed to accumulator. Move its destination source. Move it to C. So we have I equals C. Let's how do I XOR? Is there a way to clear? How do I clear a register? I think I have it in here. Set A to 0. Well, I don't know. Immediate to register. I'm gonna just say this. Clear B. B will be I. Cool. Start of loop. (16-bit) add. Load register pair to HL. So that means I need to do that. Cool. So let's clear B. So now C has the length, and the length is up to 255, so that's fine anyway. I'll clear DE. Actually, if I look at this, a move would actually be faster and less. So basically I could do like that. So basically this will be 2 bytes, 1 byte, 2 bytes, 1 byte, 1 byte. So this is going to be the end. So this will be I plus plus. We're gonna do that. We're going to decrement C and then jump if 0, jump not 0, then so basically we're going to increment DE, which will be I, and we'll use E as I. So add DE to HL, update oh god, and buff plus 2. So instead of this, we'll do increment E. Which increments E, and it's okay because 255 is the highest number of characters you can type. Double add this to HL. Let's do this. I gotta load HL. LXI H inbuff plus 2. Load base pointer for inbuff plus 2. And then you increment DE, and because I first started with 0, that should be okay. That'll be the first loop of the for loop. Okay, cool. Then let us store push D, push I, pop D, pop I. So we're gonna push and then restore DE. And I've already added D to HL, DE to HL. I now need to load LHLD. Load HL from memory. (16-bit) memory address. Now I want to load HL. No, I wanna load HL indirectly. LXI, right? I'm gonna load A from register. Load indirect. D or B. Exchange DE and HL. So we're gonna load load in buff +2 plus I to accumulator. Okay, I think that's how I get it. Load immediate, add DE, exchange DE to HL. Move HL to DE. Load. So I now have the first character. I want to store that to temp. Okay. We're going to retrieve I, and then we're going to push I back on. So we now have DE back. We have E. LXIH temp. Load temp to HL. Add D. Get plus I. Exchange. Set DE to temp plus I. Store accumulator to temp. Let's see if this even works. maybe underscores don't work well with that assembler with the cool. Okay. So let's see if this works. Load temp, get number, CPI. So I think CPI is compare immediate. One. No, hang on. Before we do any of this, LXI D temp call printf. So we're just going to print it. It looks good. It looks like I'm getting the number. Let's do temp plus 1. So now I have to do a bigger number, so let's do 42. ATOI, let's do 989, should be 8. ATOI 40000. Yep. Cool. It looks like it works, folks. Cool. So then at this point, temp should have each the number broken apart by bytes. Cool. That's pretty awesome. You guys can't read on me. They make it a little bigger. Now I need to build up the number. So build up result. So result technically should be a buffer. Like it should be like 8 numbers or something ridiculous. It should be like 8 bytes. Something big. Because ATOI, what does ATOI result in? ATOI results in an int. So this should result in an integer. Result should be 2 bytes. So this should actually be something like this. yeah, folks. Also, I'm not using Getsy or anything like that, so let's just get rid of those. I had a bunch of push and pop bees just to, because, I mean, that's what you're supposed to do. Like all these should do push and pops of the registers it uses. You know. So the actual meat of this program is this. You realign, and you break it apart. This is just all extra fluff. This is what I want to do now. Let me write this out in some C, and then try to put it to assembly. For I equals 0, less than C, plus plus. What do I want to do? Let's call this I prime minus minus. So I prime is the check for I. Let's say that. So here, what do I want to do? I'm trying to think, folks. I want to temp plus C. Cool, so accumulator equals inbuff plus 1. HL equals temp plus accumulator. So minus 1. C equals A, which is decremented. No. So this will get the address of the letter. C equals A. A is the count, so if it's 1, it will be running for 1, so that this code will run for that one time. Cool. For j equals c minus 1, j greater than 0, j minus minus. Basically, I need to because I'm working backward, if c is greater than 1, basically, if you just typed in one character, turn that one character to an int, load out D, E, and then store the integerfied and then store the integerfied M to D, E. Else so if you didn't just do 1, then I have to multiply by 10. But this will be the actual loop. I will continue this tomorrow. I don't have the brain power right now. I got a wicked migraine. But this, I think, is the framework for an ATOI function. I could be wrong, but, you know. Also, I would really love to find a multi-source assembler for CPM, but that's not here nor there. Well, I could make a tool that just like smashes them all together, but you know, what's the fun in that? Okay. Well, all right, folks. I'll see you next time.